What's going on? Let's see who's coming in here. All right. Let's going back to the questions here. For each set of numbers, graph set of numbers in line, write the set in interval notation. So the first one, x is greater than -4. So you don't have a chance to do it. You said you have done this, isn't it? Because can I see the paper? I'm gonna be take it out, cross check it out. So number 7, x is greater than -4. So what we're gonna do, we're gonna draw the number line. And Harsha and Adra, you were here when I talking about the set notation. Were you? Hello.
Yeah, I think, yeah.
What do you mean? Do you think? Were you here when I talking about this notations?
Yeah, I was here for the chart thing at the top.
What chart thing on the top? This chart thing on the top.
This
If you
one.
know that, yes. Yeah, it's the same thing here. So x is greater than -4. We're gonna going back to -1, -2, -3, -4. When x is greater than 4, for each set of numbers, graph the set on a number line and write the set as interval notation. If I want to graph it, this is going to be -4 onward. Now, in a set notation, -4, it's not going to be included, but we will go back all the way up to positive infinity. That's it. You said you had done the homework. You're just copying down. So, okay, but you didn't write the other one, right? Okay. No worries, I won't put you in trouble. Okay, doing the homework in grade 8, your parents expect that, that's my task. Sorry, I won't do that. So 8, x is less than or equal to 9. We're not going to do all of them. X is less than or equal to 9. So this is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Less than or equal to 9. We're going to be shaded. It's going to go from there. And this is going to be 9 to negative infinity. So that is something important that just to label it. Now, certain things are not quite easy to just think about it. So going back to x is not equal to 5. Divya, the class started 11 o'clock. So what's going on? Hi. Divya?
Hi.
I mean, 11:30. Divya? Oh, this is the Google Classroom code. Okay, I'm not sure where Divya is. Okay, online folks that... Okay. If you're joining online, you take the responsibility to learn it. That's what I'm going to say. If you're not learning it, you can learn it. All right. So the difficult one, not all of them are difficult one, but there are a couple of them difficult one. I would like to see how did you do 13 and how do you do 11? So you can do that on a piece of paper, sir. You have done it. So take it out, sir. Take it out so I can take the one. What? Oh, you're the one you're struggling. Okay, which one you're struggling? 10, 11, 12, and then did you do the 13? Okay. So those who are online, you can able to draw that on, you can able to draw the number line so I can see that work. So, what? 9. Yeah, I will discuss all of them. I just want to see the specific one. So let's see how he did the 11. We did a similar example like 11. Adre, how would you do 11? X is not equal to 5. On a number line, what would you do?
I would put numbers all the way up to 5 and then put an open circle at 5.
Yeah, I'm talking about a number line. How would you draw the number line? How that would look like?
Oh, it would go up to 5.
Go up to 5. That's it?
Oh, yeah.
Okay, so I'm going to be going back to taking up the solution. So that's one. You got this negative infinity less than -7. That's right. So, and then not equal to 4. Okay, yeah. Okay, let's going back to talking about how we're going to do the 11. So the 11x is not in less than 5. So all you're going to do is on a number line, you're going to simply have the 5 will be little bubble, and then you have to shade it in both directions. You have to shade it on both directions. That is what it is. If you didn't do like that, then there's no Padma here. So that's the right way to go. But how do I write that in a number line? I mean, set notation, interval notation. So this is the number line. In interval notation, I will write that negative infinity, -5. do not include that. Union, 5, not -5. So that is negative infinity, -5. And then from 5 to positive infinity. In other way, take every single number on the real number, but do not take 5. Now, let's going back to number 9. How do we do the number 9? Number 9 is between -10 to 10. So pretty straightforward to do the -10 to 10. This is 0. This is going to be -10. This is 10. -10 to 10. Start from here, but do not include. Include 10. Do not include 10. So it is going to be every single number that's going to be between here. So how do I do that on an interval notation? I will start from -10. Do not include it. Go all the way up to 10, but include the 10, right? Are you following that, sir? Okay. Now going back to the 13. So how do we do the 13? X is not equal to 4. So if I want to do that on a number line, it says two conditions need to be satisfied. X is not equal to 4, but X is less than 17. So what we're going to do, we're going to think about anything that's X is less than 17. X is less than 17 supposed to go this way. With that, you need to make sure X is not equal to 4. So what do we do? At 4, we will put a little bubble. At 4, we will put a little bubble and then go all the way up to 17. But 17 must be included. That arrow mark goes from here. So how do I write that in an interval notation? I'm going to start from -infinity, go up to 4. You can see that 4 is not included. Union. So include that. Then we're going to start from 4, go all the way up to 17, include that. So we have to be really careful. This need to satisfy both conditions. It is not or, it is and. So, and mean X is less than 17. Also, meantime, I need to satisfy the condition that X is not equal to 4. Can you follow that, sir? All right. Now, something we have to be really careful here. This sign in the middle I use is not correct because this is to tell us, oh, this is basically X is this or that. So we cannot use this sign in here. We need to use that sign in this case. Both condition has to be satisfied. Otherwise, it's going to be this or that. So it can be X is not equal to 4 any numbers or X is less than 17. Online folks, are you guys following what's going on?
Yeah.
Okay. So I believe the rest is pretty straightforward. You did the other one, sir? 10, 14? Huh? Did you write that in a set notation? Interval notation? 14, no. 10, you did it in interval notation? Let me see, how did you do that? 10. 10 goes away. Oh, 10, you need to help it. So X is 1 to 20. So we're going back to 1 to 20. So this is 1. This is going to be 20. You can see that 1 to 20 inclusive. So we're going to do the bubble. So that's going to be 1 to 20. Or X is greater than 30. So what's going to happen from 30? You're going to have this. This is what's going to happen. Now, how do I write an interval notation? Well, pretty straightforward into going back to the interval notation. So it's going to be 1 to 30. You can say inclusive. Union. So that's still O. You start from 30. So, 20. That is 1 to 20. Union. Then you start from 30. You go to positive infinity. So you have to be careful here that we have to include both 1 and 20. Union from 30 because it's greater than 30, not including 30 all the way up to infinity. My online folks, are you guys following that?
Yeah.
I only hearing from Adrai, so let's see what the rest is. The rest is on there. Okay. What you guys going to do? What the rest is doing? Meta Quest. Okay, let's see who is in here. Harsha and Divya. I only see Adra respond yes. Are you guys there in the class?
Yeah.
All right. All right. It is grade 12, right? But there's always a solution. Ontario Virtual School. Okay. When the semester begins, I always have an issue with the administrators because they see my name in teaching advanced function, they straightly go to the guidance counselor and then say, I didn't even start teaching it. Before my class starts, if it is in the evening, they will go to the guidance counselor and say they want to take a night school. And the guidance counselor will say, no, you cannot take night school because we are offering here. So they know they can be a part-time student. They cannot drop the class. They have to register. They cannot take as TDSP or any school, any public school board. So they go to enroll in private school. And then I know the kids enroll in private schools. It's easy to mark. They'll be still in my class, but I have a blank test. Okay, that's okay. And if you're not paying attention, it's going to be. So we talk about last class, the absolute value functions. What I don't really worry about it, I don't really worry about talking about this. And then we also talking about an odd and even function. I believe that you guys missed that lesson, odd and even functions, if I'm right. Hello.
Yeah.
Okay, it's perfectly fine. I can revisit that. It is not going to be interfere with my lesson for today. And then we can revisit that maybe when you guys see a full class. So I'm going back to my handout for today. How's your the Waterloo math course going on? Pretty good. Who's teaching it? Oh, so instructions marking your assignment. So using Brightspace D12. Oh, you submit through the crowd marking, but where the course content is posted? Oh, so they're using a different platform. Okay. What they're focusing on? The high school content or just going beyond? I see. Okay. Okay, MHF for you handout, not this handout. I'm using my school handout, so that's the handout I'm using. It functions. So we're gonna moving back to today, properties of the graphs. So we're gonna talking about properties of the graph and special focus on something that you guys have seen before. So this is what we're gonna talking about. So what I'm gonna do, I'm gonna be sketch the graph, and then from there we're gonna talking about how to answer these questions. So first graph, pretty straightforward. Everyone know. So that is going to be the shape of straight line. Now, what we want to talk about it, we want to write the domain and range in both set and interval notation. So what I will do, I will write them in first set notation. So in the set notation, it's going to be x belong to real. There shouldn't be no problem with that. You guys have seen this before. But we want to state the domain in interval notation. Divya, how would you write the domain in interval notation?
Like the bracket, like the curve.
I can, sorry?
The curve bracket, and then negative infinity, comma, positive infinity, and then
Correct. That's right. So that is going to be a C bracket starting from negative infinity to positive infinity. This is going to be that interval notation. Now, this is pretty straightforward. I don't really need to worry about it. So again, then I'm going to be put a curly bracket here. So that is going to be my interval notation, negative infinity to positive infinity. Now, something that we need to talk about, interval of increase, interval of decrease. So interval of increase mean from when x goes from left to right, if the y values, what's happening for the y value? Interval of increase. When x goes from left to right, we need to see in where the y value is increasing or decreasing. So if you guys really looking at this graph, this is where I start. This is the left point. Let's look at the y value here. So if I'm going to be extend this graph, let me put some dot, 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 dot. This is my first y value. When x goes from left to right, then I'm going to be going back here. So this is my first y value. This is my second y value. Let me keep on going here. So when I keep on going to left to right, when I come over here, this is my y value. Let's call y3. Let me come over here. This is my y value. So the question here is, in this graph, when I go from left to right, what is happening for the y value, sir? Comment. When I go from left to right in X values, what's happening for the Y value? Increasing, decreasing, increasing and decreasing, decreasing and increasing and stay the same. It is decreasing and increasing. So what's happening here? It's keep on increasing. How come you can say decreasing, increasing, man? Look at the bottom negative value. So you on a negative infinity, when the Y value, X values go to the left to right, it's keep on increasing, isn't it? You come to the positive value. So how come that increasing and decreasing? It is keep on increasing. Does everyone see the picture? Look at the Y values, the negative axis, put that in horizontal. You start at -5, -4, 0, 1, 2, isn't it? Hello? My online folks,
Yeah.
are you guys following that picture?
Yeah.
This particular graph is always increasing. So always increasing, I'm going to write the interval of increasing using interval notation, negative infinity, positive infinity. Harsha, what is the interval of decreasing?
I don't know.
So let's going back to how to think about decreasing interval. When you're looking at the graph from left to right, you need to ask yourself, does the X, Y values on the graph are increasing, or Y values on the graph is decreasing, or they are increasing somewhere, decreasing somewhere? So let's look at the picture. When I take the X value from the left to right, what's happening to the Y value based on the graph? Look at all my green plots. We discussed that clearly, precisely on the previous one. We talk about that here. We can clearly see in this thing. So if you say, I don't know, you didn't get this. Did you understand this part, interval of increasing?
I understand that it's going up, those green points.
Okay, it's going up versus increasing. They are completely different terminologies. Increasing versus going up. Increasing means the values are increasing. So they are in least to greatest, isn't it? So let's ask yourself, do you think the Y values are decreasing anywhere in the graph?
No.
So not available. This graph is only increasing. Turning point. The turning point to look at it, does your graph turn like this? Turn like this. Does your graph have any mountain, whole valleys? Do we have any turning points? No. So we don't have any turning point. Discontinuities. So Audrey, does the graph has any discontinuity?
No.
Zeros. Let's ask Harsha. Does the graph has any zeros?
No.
How come? Zeros mean, and since grade 10 you're learning it, does the graph take Y value 0?
Oh,
Does
yeah.
the graph take what? Okay, so zeros is where Y value is 0. That's happening. The zeros happening when X is equal to 0. When X is equal to 0, my Y value is 0. Y-intercept. So Y-intercept is happening at when Y is equal to 0. So that is my Y-intercept. Symmetry. We will talk about this a little later, symmetry, but this graph known as having a point symmetry. So point symmetry. Let me explain what is point symmetry is. Oh, we can call it rotational symmetry. Let's call that rotational symmetry. So let me explain what is rotational symmetry is. If you have a point X comma Y in the graph, if the same point is going to be captured in negative X comma negative Y, then we call the graph as a rotational symmetry. We did talk about when you guys are away. I will revisit that. When a graph has rotational symmetry, so that's on the slide, rotational symmetry, the graph is an odd function. We will revisit that again just for the key point. Now, end behavior. So what is end behavior as? We want to see the graph when X goes to infinity, where the Y goes to, when X goes to negative infinity, where the Y goes to. So let's look at the graph. If I keep on extending this graph, when X goes to infinity, When x is going to infinity value, where do you think the y value goes to, Harsha? When x value is going further on the x-axis, where do you think the y value might goes to?
It's also increasing.
Not increasing. I'm asking where the y value will go to. What value will take when x value going to close enough to infinity. So if
Y.
I'm going to keep, yes, y will go to infinity, correct. Y will go to infinity. You can see that if I extend the graph, I can keep on extending. Now, something you need to look at it. When x goes to negative infinity, when x goes to the negative direction, we can clearly say y is also going to negative infinity. Are you guys following that? Obvious, isn't it? So that's my first graph. Now comes to some interesting graphs that we're going to discuss. Hi guys, are you guys following the picture? Okay, this lesson is being recorded. I will send the recording to those who want to. I believe only Harsha has to leave in 1 hour, so I will send that link. So you should be able to watch it. So moving back to the next graph. I can ask you guys to actually copy down that work for me. So I'm going to sketch the graph y is equal to x squared. So that is how the y is equal to x squared curve look like. This is the point 0. I also going to sketch the 1 over x curve. The 1 over x goes like that. Adare, how do we call the 1 over x function? What's the name for the 1 over x function if you remember from grade 11?
Is it like reciprocal?
Correct. Reciprocal function. This is an absolute value function. You guys have seen that in grade 11 too. So that is how the shape of the absolute value function is going to be look like, little V shape. Okay. Now square root of x is known as the square root of function is going to be go like that. Exponential function also, you have learned that something to know. This is going to be 1, so it's going to be go like that. So you have all learned these functions before. No question on that. You have learned those functions. I'm not introducing chapter 1 anything new. What we focusing on, you can see that how do we write things in set notation, right? Okay, so can you guys do quickly gx is equal to x squared table? I want you guys to complete gx is equal to x squared table. And let's see if you can able to write them correctly. So, Janish, I teach summer school credit course. So to make sure that kids won't take, kid won't cheat, that we do a code adjust platform. So because Replit is right now, you had to pay for it. So code adjust doesn't have an AI enabled, but you can see the history. So if a person asks ChatGPT, and then I can see it because they get a copy and paste the whole code. So the requirement is you need to type every line in that platform. So if you're not typing it, it's 0. That's fine. A kid who first say he couldn't able to access code adjust. Okay, so I know that he didn't want to write coding. Then I just sent several emails, send a link directly. So he got the code adjust. I'm teaching programming in Java. He's doing the assignment in Python. Okay. The only annoying part is my administrator is not a computer science teacher. We used to have a computer science teacher. Somehow, politics, they remove her. So it's going to be fun email to explain what we're learning. Imagine explaining an administrator had no clue about math and math cheating. All right, so let's move on. Domain. So let's start from Divya. What's the domain, Divya?
Do you want both set notation and the normal one?
Yeah, both of them. You're going to tell me in both.
The curly bracket, x belongs to reals, and then the curly bracket. And
Yep.
Set notation, it's the C bracket, negative infinity, comma, positive infinity bracket.
Okay, cool. So you're tasked to tell me all of them. I'm going to go back to each one of them to give. So what is the range?
Me?
Yeah, you're gonna tell all of them for me.
Oh, okay. The range is x belongs, curly bracket, y belongs to the reals, a line, and then y is greater than equal to 0, and then curly bracket.
Okay, pretty good. How would you say that in set notation?
C bracket, positive
Sorry,
infinity.
what bracket?
Bracket?
D bracket, okay.
No, C bracket.
Oh, C bracket, okay. C bracket, okay, yeah.
Positive infinity, comma,
So
0.
you say positive infinity?
Yeah.
Okay, comma.
0,
Mm-hmm.
D bracket.
So something you need to know, this should be the starting point, that should be the ending point. And remember, positive infinity is sitting far away from 0, isn't it?
Yeah.
So that has to switch. You have to start from the starting point to the ending point. Make sense?
Okay.
Okay, cool. Interval of increase. Okay, I'm gonna stop. I'm gonna going back to Harsha. So Harsha, when you want to look at for the interval of increase, something you can look at it. The graph's supposed to be take a shape like this or shape like this. This is the interval of increasing shape. When I say interval of decreasing shape, you need to look at it where the graph go like this. That's basically the shape to look at for increasing. And then that is basically the shape to look at for the decreasing. So that's being set. You can tell me an interval notation, the interval of increase.
There is increasing and it's
Sorry, what do you say?
there is increasing in the graph.
Yes, so what interval? I want you to tell in the interval, which interval is increasing.
Zero to infinity.
Correct. So we're going to say that start from 0, including, and then go all the way up to the positive infinity. That's increasing because you can see the shape there. Okay, how about interval of decreasing?
Would it be like negative infinity?
Correct. All the way up to
0.
0. Because 0 is the common point, what we're going to do, we're not going to include a 0 in both places because 0 is common for both of them, increasing and decreasing. So we're going to put that with a C bracket. So turning point. At what point the graph is turning other way?
Like
Where?
at the vertex, like 0, 0.
Correct, at x equal to 0. So the number of turning point is equal to 1, stand for number of turning point. Discontinuities or asymptote. Do we have any discontinuities or asymptote? Does the graph break anywhere, Arthurite?
Oh, no.
So that's not available. Zeros. Where do you see the zeros are?
Oh, who, me? Me?
Yeah,
Like at like x is equal to 0. I mean, like,
x equal to 0 is there, the 0 is. Y-intercept, you can clearly see y is equal to 0. Symmetric, the graph has a symmetric, it's called line of symmetry. So it's a line symmetry, The equation of the line symmetry, x is equal to 0. So it's basically equation of the axis. End behavior. So let's see, Kevin, what is the end behavior? So when x goes to infinity, and then when y goes to infinity, what's happening to, when x goes to positive infinity, x goes to negative infinity, what's happening to the y? Kevin. When x goes to positive infinity, y goes to negative infinity, what's happening to the y? Positive infinity. Both sides goes to positive infinity. Graphs goes like that, isn't it? All right. Going back to the next one. The next one is going to be a little interesting. There are a couple of them is going to be interesting. So Harsha, what is the domain? I want you to tell me the domain in interval notation.
Okay. Is it, wait, One is like negative infinity to 0.
Okay.
And then I forgot there's like a symbol. It's like a U.
Okay, you, yes. So you correct.
And
So
then
my question is, should I put this or the other one?
no, it's just like the
C,
same as
C
the
bracket?
yeah.
Okay. Okay, you, yes.
And then the opposite, like positive infinity and 0.
Well, you need to start from 0, go to positive infinity. Correct. Because 0 is an asymptote. So we're not going to include 0. All right. Now it comes to range. So let's see. Right. Can you tell me the range?
The range is like, do I just say the set notation or like?
Set notation, yes. I mean interval notation. We're going to stick with the interval notation.
So like it's gonna be like negative like negative infinity and 0,
Mm-hmm.
and then that u thing,
Mm-hmm.
and then 0 to infinity.
Correct. Because it doesn't take y value 0. Now it comes to interval of increasing, interval of decreasing. So this is a little challenging. So let's go back to Kevin said. Interval of increase. So how to visualize it? You're going to be draw from the x-axis, right? From the left side of the x-axis, you're going to keep on drawing some y value. So from the left side of the x-axis, we're going to draw some y value. So that's my first y value. Then I'm going to have my second y value. Then I'm going to have my third y value. Then this is my next y value. Then my next y value. Then my next y value. So left to right, we need to visualize the y value. So if the y values are increasing, there's an increasing interval. If the y values are decreasing, there's a decreasing interval, right? So what is the increasing interval? Janusz? There is none. So no increasing interval, because you can clearly say my yellow marks is going further down, isn't it? Going from left to right. So have you seen a picture? Huh? So if I draw a red line, this is my first y value. Make sense? Then when I go to left to right, this is the first point. Second point, my value come down. And here my y value come down. So that is -1, that is -2, this is -9. -9 is smaller than -1. So the y values are decreasing. Make sense? What? Oh, my red line, how come it's not reflected? That's kind of weird. I draw the red marks. Let me erase this. Is that being frozen? Oh. I'm sharing my screen. Let me stop sharing. Okay. Let's see. Interesting. Okay, I'm gonna stop sharing, reshare it. Okay. All right. Okay. Start broadcast. All right. Now going back to my screen. All right. So let's going back to the absolute value function. So we're gonna be draw the first x value. This is the y value. So let's call that -1. Then I got here, which is -2. Then I got here, which is -9. So when I go from left to right, you see that the corresponding y values are decreasing. Similarly, if I do the other way around, so this is my first y value, that's my second y value, that's my third y value. When I go from left to right, we can see that y values are decreasing. So there is no interval of increasing, but there's an interval of decreasing in interval. So can you tell me, sir, in which interval is decreasing? Yes. Yes. Correct. Because 0 is an asymptote, so we cannot include that in our interval. The graph doesn't turn anywhere, not available. Discontinuity asymptotes, yes, we do. We have 2. There's a horizontal asymptote. Horizontal asymptote. You can see my when the x values are going to infinity, by y is going close enough to 0, isn't it? So the horizontal asymptote is known as, so the horizontal asymptote is y is equal to 0 axis. Vertical asymptote at x is equal to 0. Why vertical asymptote x equal to 0? Because we have 1 over x. It's not defined in x equal to 0. All right, so let's go back to Divya. Do we have any zeros?
No.
Not available. Do we have any y-intercept? Not available. Symmetry, not available. This graph is not symmetric. And behavior. So that's little interesting. So let's ask Harsha. When x goes to positive infinity, x goes to negative infinity, where the y goes to? Look at the graph.
Y
When
would be
x goes
like
to-
0, right?
Correct. That's right. Y goes to 0 because that is part of your horizontal asymptote. All right.
I have a
So
question.
yeah,
Can't you draw like a slanted line through the graph and then it is symmetry?
sorry.
Like if you draw a line like angular, like isn't it symmetrical in the graph?
You mean that, and you mean a line through y is equal to x-axis?
Yeah.
Yeah, we only consider the symmetric through two things: a line symmetry. So if you can fold a graph into two halves, the other one's called rotational symmetry. So basically, we take one point in the graph, we rotate it back 180 degree. It's going to be just come back again. That is going to be the rotational symmetry.
Okay.
Okay. Let me going back to see one thing. Because that's an odd function. Okay, because 1 over x has, let me double check my symmetry. It might have a point symmetry because there's a point 1 comma minus 1. Yes, you're right. So this one has a line symmetry for a reason. It has a line symmetry. It has a point symmetry. So rotational symmetry, point symmetry. Let me explain point symmetry or rotational symmetry. Why it has the point symmetry or rotational symmetry? Think about a coordinate 1 comma 1. Think about coordinate 1 comma 1. We do have a coordinate negative 1 comma negative 1, isn't it? Because it's 1 over x. All right. So I'm not going to be go through these two. So that's something for you to practice writing that. You can put that as your homework to practice writing the interval notation. So the absolute value of x, square root of x, and exponential function. The goal here is we try to visualize, or we try to learn how to write things in interval notation and set notation. So when it's come to the graph, we're going to be able to tell the following properties: domain, range, interval of increasing, interval of decreasing, turning point. A point with a curve where the function changes its direction. So go like that, go like that. Discontinuity. For which value of x the y value is not defined. Asymptote, you have learned in grade 11. Zeros, you have learned in grade 11. Y-intercept, you have learned in grade 11. Now, a function may have a line symmetry or point symmetry. We will talk about that. Last not least, and behavior. So what we want to talk about here, identify the interval of decrease or increase, turning point, and in behavior of the graph below. So that is something we're going to do for practice. I'm going to mark these as the right value for you to visualize: -1, -2, -3, 1, 2, 3, 4, and -1, -2, -3, -4. And this is -4. Can you guys complete all the information based on the graph? Let's see. You're going to be right, all of them in a set notation: increasing interval, decreasing interval, turning point, and an end behavior. Good answer. Because that's especially interval of increasing and decreasing. You need to be really careful. How would you do that? Look at the picture. I already mentioned how to look at for the increasing and decreasing interval, because there will be multiple here when it's come to increasing interval or decreasing interval. So you have to be really careful how to state that. Good answer. Okay. All right. So I'm gonna be do just one clarification. So we're gonna be say this is one. So to make sure that's picture like that, so that won't confuse. So let's going back to the right. What is the increasing interval you have mentioned?
The increasing interval.
Mm-hmm.
Is it like I don't know, like negative, um
Keep in mind, if a graph goes like that, that's a shape increasing. If the graph goes like that or goes like that, that's a shape is decreasing. So that is going to be increasing shape. This is the decreasing shape. So you have to look at the graph in that format.
I mean, like there is, because like it's like going up there kind of.
But what from which x value to which x
Oh,
value?
to like -2 to like 1.
Correct. -2 to 1. That's right. And then we're not going to put inclusive because they are the boundary. So when things are in the boundary, we're not going to put that as an increasing, inclusive. So now we're going to go back to decreasing interval. So Kevin, which interval is decreasing, sir?
Um, 4 and 1.
4 and 1.
1 and
I want that exact answer in set notation, interval notation, sir. Just saying 1 and 4, it's not an interval notation. Exactly in interval notation. But something to note, when the arrow mark basically saying that is going forever. That arrow mark specify the graph is going forever. Decreasing in tone. Okay. This interval means it would be two numbers. It just clearly shows that which shapes to look at here, right? Let me go back to Harsha. Harsha, decreasing interval.
One is like -infinity to -2.
Correct. That piece, sir, that piece. Don't you see that piece? Perhaps goes like that. Okay. Where else?
Oh, me?
Yeah.
Oh, the other one's I think 1 to positive infinity.
Got it. Yes. From 1. Don't you see that, sir? It's visualizing piece. All right. All right. So we talk about increasing and decreasing interval. Turning point is obvious. We see that graph is turning in 2x values. X is equal to -2, comma, x is equal to 1. And then end behavior. So let's going back to Divya. What is the end behavior? X goes to positive infinity, where the y goes to. Okay, let me ask you, sir, Kevin. When x goes to positive infinity, where the y goes to? Kevin. When x goes to positive infinity, where the y goes to on the graph. When x goes to positive infinity, where do you see the y goes to? So when x goes to positive infinity means when this line is being extended further, where the y goes to, imagine when this line is extended further, I can keep on extended further. So where the y goes to? Yes, why it's take that long to think about that? Okay, so when x goes to negative infinity, Harsha, where does the y goes to?
Is it also the opposite? So positive infinity?
Yeah, it goes to positive infinity because negative infinity this way, and the y goes to this way, isn't it? So you can do as many practice you want on this, but as long as you're not visualizing it, that doesn't matter. A 10,000 example won't help because you're gonna be get a curve that you never seen before. So it's very important that you know how to master stating that increasing and decreasing interval. There are plenty of example on the Waterloo CMC. We can do some practice, but we want to move on. We will revisit this for practice. So I'm gonna going back to PDF. So 1.4 transformation, yes. So we're gonna moving back to, I think I print this sheet. So, oh yes, this is, that's a PDF file. I can only insert it. Who's coming in here? Ashini, where were you?
I'm here.
I know, but where were you? The class at 11:30. I asked everyone if you guys can come in 11:30.
Yeah, no, sorry. I had to go to my music class early in the morning and then I got dragged.
Okay. Okay. 1 second. Why does it not allow me to insert this file PDF? Let me close this, open it. Oh, no. All right, that is grade 12. Image for you. And then that's chapter 1. You guys got that transformation PDF. Okay, here we go. All right, so we're gonna going back to see how we should be able to state the domain and range for various functions. So that is what we want to talk about. This is simply a practice from grade 11, nothing else. There's nothing new. It's a complete grade 11 practice. So if you really focus on my grade 11 class, you should be able to answer those questions. So let me going back. You all have the sheet. All right, and then we're gonna going back to stating that in set notation, various notations.
I have to go. Can I?
Yeah, that's fine. I'm recording it so that you should be able to see. Make sure that you watch the recording for we will meet next Sunday.
Okay.
Okay. All right, so we're gonna going back to the functions. I'm gonna be tell the first one set notation and interval notation. So we're gonna going back to the first one, pretty straightforward. So obviously you know linear relation. So we need to state the set notation, the domain x belong to real. So this is an easy function to write. And then I'm gonna going back to interval notation, negative infinity, positive infinity. The range of for this one is going to be y belong to real, pretty easy function. And then we're gonna say negative infinity, positive infinity. No problem on that. Pretty straightforward, right? All right. Now comes to the fancy functions. Can you guys do the second one, please? Set notation. This is a complete review for all the stuff that you have learned in grade 11. All right. So let's ask Harshini, what is the set notation of the domain for that function? Harshini? Hello.
Yeah, you're like glitching.
Am I glitching? Okay, let me ask Adore, can you hear me?
Yeah, I can hear you.
Okay. What is it? What is the set notation for the domain? Harshini. Adore, what is the set notation for the domain?
It's like x is like less than equal to negative 5/2. 5/2, I think.
Well, first of all, x belong to real,
Oh.
and then you say x is less than or equal to 5/2.
No, the other way. Greater than.
Okay, so that's supposed to be greater than or equal to 5/2. Okay, x is greater than or equal to 5/2. Yeah, she's right. Because it's a square root function. We want to make sure 2x minus 5 is greater than or equal to 0. So x is greater than or equal to 5/2. Correct. So writing that in interval notation supposed to be pretty straightforward. Kevin, how would you write this one in interval notation, sir?
Um. Positive and
I'm talking about that the highlighted one in interval notation. X is greater than or equal to 5/2. So you have to put, there's no way you can think on ahead. That's an Albert Einstein word. You need to draw the diagram. This is 0, this is 5/2. Then we want something 5/2. That's how it's look like in number line. Then that will allow you to visualize. Where do we start? What's the starting point? 5/2. So we start from 5/2. And then it says include the 5/2. So we're going to include the 5/2. Now the question is, where is the ending line?
positive.
Yeah, so we're going to put that. That's it. All right. Now the next part is the stating the domain. Range is what the challenging part. Harshini, you're back. What is the range in set notation, Harshini, for the next one? Can I
Yeah,
see you, quick, sir? Hold on. Just give me a moment. Okay. Yeah, you still didn't say why belong to real, sir. Right? Yes. Harshini. What?
y belong to all real numbers. Y is
Mhm.
less than or equal to 3.
That's right. Y is less than or equal to 3. Correct. All right. Now, writing that in the interval notation. So I'm going to be just again recall that 0. We got a 3. So we're going to start from 3 and going onward. So now the question is, where do we begin? So this is what we have to be careful. We don't begin here at 3. We begin in negative infinity. And we end at 3. And then 3 is inclusive, isn't it? Make sense? Did you put -3, sir, somehow? Okay. All right. So this is full practice. So we're going to be focusing on some specific functions to play around with it. So let's going back to, we need to practice this. So let's going back to next 2. So can you just complete the next 2? I'll be back. Copy the reciprocal and then also the exponential function to see how we just do that.
Wait, for the second one, f of x is equal to -2 to the power of, is that a 2 or a 3?
This one?
Yeah, okay, that's a 3. Okay, thank you.
2 to the power of 3x. 2 to the power of 3.
Thank you.
No problem. All right. Wrapping that to answer that question, sir. Okay. At least that's a smart way to go, but you're not allowed to do that on a test. Okay. So let's moving back to the set notation. So we're gonna going back to the first one should be pretty straightforward. So writing the domain is easy. X belong to real. X is not equal to 0. There's no question on that. So you can see negative infinity is 0, union 0 to positive infinity, isn't it? Okay. Now we're gonna going back to this one, set notation. How we're gonna tell the range. The range for this function is you should know that this is going to be the horizontal asymptote. So your graph is not going to be crossing that point. So y belong to real, y is not equal to -1, isn't it? So how do I write that in set notation? Negative infinity, -1, union -1 to positive infinity. Did you guys write that on the other side? Andre? which one is correct, which one is not correct? Hi.
Hi. Which one?
So did you write that correct for 2
Oh.
over negative x?
Yeah.
Okay. So now we're going to go back to the exponential function. So you should know that exponential function x will always take the positive. X is going to be take both negative and positive value. There's no restriction on the domain. So x belongs to real. And then negative infinity to positive infinity. The range, you need to visualize this. So this is going to be your asymptote, but it'll take the value. All the value is going to be, so if you guys sketch that, so if you guys going to be sketch that exponential function, this is how the exponential function is supposed to be go like this. When y is equal to 2 to the power of x, the domain is going to be, range is going to be y belong to real, but y is greater than 0. So y won't take this value. When it's 5, I won't take that value. So it's going to be greater than 5. So y belong to real, where y is going to be greater than 5. So how we're going to write that greater than 5? So that's going to be unset notation. This is going to be 5 to positive infinity. Are you guys following that picture? Hello.
Yes.
Hi. Okay. Now let's what Kevin is doing it time to time. We can also visualize the graph. So let's going back to on decimal plus y is equal to 2 to the power of 3x plus 5. So I want you guys to observe. So, and then I'm going to say y is equal to 5. So if I really zoom in, you can see that it's look like touching, but it's not touching, isn't it? So you guys can see that. All right, so let's keep moving to that. So, all right, so which one I really want you guys to think about? We're gonna going back to the absolute value function this time. So can you guys look at the absolute value function to state the domain and range? If you can visualize it, sketch it. Right, that's the best way to go. Hey, did you shop at Costco? No, I'm asking, did you shop at Costco? Yeah. Do you have a Costco card? Yeah. Okay, I'm gonna say. You try to get a calculator for you. Yeah. Yes, the cashier one, but we had a smile calculator goes. Same, this one, I like this one. It's pretty good. Double display. Costco always have for 12. Oh wow, $37. Where's your dad is checking it out? $37. Okay, I'm gonna send him. Unless that you want to be generous having the fancy calculator. I didn't see for a long time. Oh, he still has it. Okay. So your school still allow that in grade 12? I know, but grade 12, they're perfectly fine with that. My kids are gonna hate me, man, forever. Okay, that's okay. Let's moving back to the next one. Absolute value function. This is a little interesting. Let's see. Divya. So what did you say for the domain? Divya?
X belongs to real.
X belong to real, no restriction. X belong to real, 100% sure. You can say no restriction for absolute value function. Now we are looking at this one. This is a little interesting. So the plus one is going to play the role in the graph. So in terms of the domain, y belong to real, y is going to be greater than or equal to 1. Okay. Now, because it's absolute value, it's always positive. You're adding 1. And then in terms of the interval notation, so we can go from 1 to positive infinity. So that is how to just look at it. The minimum absolute value can get 0. All right. The next one I wanted to see, how would you guys do this guy? Can you guys look at the exponential function? All right, so that's going to be a little tricky. Certain things we can guarantee. So let's go back to Harshini. Harshini, what did you say the domain?
I said X all real numbers.
Yes, because exponential function, x all real numbers. So that's pretty easy to tell. Now we're gonna going back to the domain. Okay, what is the domain? What is the range you got?
For the range, I got y all real numbers. Y is greater than 0.
Y is greater than 0. That's it. Because when there's nothing here, just not gonna take any values. And then we can say that from 0, not 0, it's just going to be 0 to positive infinity. I'm going to let the rest for you guys to practice, so I'm not really worried about it. Something that we need to be really careful this one. So I'm going to be saying that we need to be careful. What you guys didn't realize that there's a negative x plus c. That's going to be screw you up. So let me going back to the graph quickly. So if you have y is equal to 4, what is this? 3/4 of the x. This is something you need to be really careful. 3/4 of the x, the graph is going to be something like this. It's exponential decay, isn't it? Now, if you have a negative x, that is going to be reflected the graph on which axis? X-axis. So if I'm going to reflect the graph on the x-axis, the graph is going to go like that. Are you guys seeing that picture? Hello. Hi. So that will affect my range. Y belong to real. Y is less than 0. So how do I do that? Negative infinity is 0. Harshini, are you following that? This minus is crucial. Okay. So you can say now, in terms of homework, it is going to be textbook question. So I'm going to go back to the textbook question, how this is aligned with the textbook. The textbook, what's happening on here? It's a first unit is full of reviews. You can see that on function unit you have learned. So we finished just doing this. I want you guys to copy the rest. And then there's the mid-chapter review comes in. And then sketching graph of function. So that's basically using transformation. So we have been talking about different pieces here. So on the textbook, you're going to say state the transformation defined by each equation in order to be graphed. Then identify the appropriate value for A, K, and C, and ordered pair, list the ordered pair belong to each. So what we're going to do, we're going to spend a little time on doing this to make sure you really understand what's going on. So we talk about a domain and range. Time for us to practice. I will do some selective questions Okay, so to do that, I'm gonna do some selected questions to practice to see how would you guys do the domain and range. Whole transformation about a function. All right, math number 2526, amateur for you. Done, done. Okay, so let's get started with this question here. State the transformation identified by each equation. I'm not really worried about the easy one. We're gonna going back to the complex one. So let's get started with the complex one. Let's start from F. Kevin, you have learned functions with themselves. Okay, can you tell me the transformation you had to apply for f of x?
Vertical stretch by a factor of
You can say vertical stretch by a factor of 1/2. That's fine. Vertical, you don't need to be switch it. Sometimes people say just compress, or you can say vertically compressed by a factor of 1/2. That vertical part, you can say vertically stretched by a factor of 1/2. That's fine. Okay, what is next? So a function will go through following x minus d plus c. A is going to be vertical structure compression. This is going to be horizontal structure compression, but we had to be really careful. When the k value is less than 1, it's going to be stretch. How do I tell the stretch? Vertically stretch, horizontally stretched by a factor of 4. That will be flipping. This is because his middle sign is minus, horizontally translate to the right by 5 unit, vertically translate translate up by 6 unit. Are you guys following that? Okay, makes sense, sir? Okay, Ash, let's go back to Adre. Adre, can you describe the transformation E, please?
Oh, that's like a reflection. A compression.
No compression. So where do you see the compression? So unless the A value, if the A value is equal to 1, there is no structure compression.
Oh.
A value is -1. The absolute value of A is -1. So if your absolute value of A is 1, there won't be no structure compression. But if the absolute value, yes. Yeah.
but
What?
can you finish this?
Yeah. So the minus is going to be reflect on the x-axis. Make sense? Hello?
Yeah.
Hello? Okay. So that is going to be reflect the graph on the x-axis. Now this one going to be reflect the graphs on the y-axis. So we're going to say vertically reflect. Horizontal reflect or reflect the graphs on the x-axis. So E is going to be reflect on the x-axis. X-axis. Then it's going to be reflect on the y-axis, isn't it? Make sense? Then horizontal translate to the left by 2 unit, vertically translate down by 3 unit. Are you seeing the picture?
Yes.
Okay, Harshini, can you describe the C?
Yeah. Horizontal translation to the right.
Before horizontal translation, don't you see the negative in the front?
Yeah, reflection in the x-axis.
Okay.
Horizontal translation to the right 3 units and vertical translation up 2 units.
Correct. Okay, let's go back to Divya. Can you tell D, Divya?
Vertically stretched by a factor of 2, reflection in the x-axis,
Mm-hmm.
and horizontally compressed by a factor of 1/4.
Correct. That's right. Okay, now we're gonna moving back to the next set of questions here. So that's pretty straightforward. And then finding that A and K and C and D is not a big deal. So this is a find A, K, and C and D. I'm not really worried about it. All right, so I'm not really worried about number 5. I'm worried about, so I'm going to be talking about number 9. So I'm going to be let you guys do the number 9. I'm not going to tell what to do, but you guys going to be do the number 9. Image for you. That's in an image. Oops, that's in should we go to image for you? Okay. What did I didn't do? I say go to image of for you. Okay, sent. Okay, cool. Okay, so we're gonna moving back to that textbook question here to see it. All right. So the question I want you guys to do, number 9. Number 9. Let's do the little difficult one. You guys gonna do B and then F. I'm not gonna tell what to do, but let's see. But let's recall. Recall. You might have forget things. If a function f of x going through the following transformation, f k x minus d plus c, if you have a point x comma y, this point will be transformed into x over k plus d comma ay plus c. That is something I can tell that you should remember from grade 11. So can you guys do the D and F, please, using that formula? What your sister's doing? Summer, did you take any courses? Oh, the Tamil credit course. Okay. Online or she has to go to class? Your mom need to go to work 4 days now?
Yes.
Oh, so she's still CIBC's, it worked for CIBC, right? CIBC being nice. Okay. Not in September, they're not asking. Oh, okay. All right. So let's see. All right. What did you get for B?
Like the transformed point.
Yeah, to the transform point, yes.
I got like 4. I mean, like negative what like 1/2, and then 4.
Okay, so let's negative 1/2, and then you say 4?
4, yeah.
Okay, so let's going back to the transformation. F2 x plus 1 minus 4. So k is equal to 2, d is equal to -1, and c is equal to -4. So let me plug it in, and then a is equal to 1. So if I plug it in, so 1/8 will go through x over k. 1/k is 2 minus d minus 1, comma ay. Just a is going to be just 1 times y, 8, and plus c. C is -4. So that is going to be -1/2, comma 4. Yeah, you got the right. That's right point. Okay. Now, let's going back to Harshini. What did you get for F?
I didn't finish yet.
Okay, I'm gonna wait. Do your math.
Is it 1? Is the answer -1, 7?
right, sir? Okay, -1, 7. So let me quickly do that. A is 0.5, K is 0.5, and then D is -3, and then C is +3. So if we do X over K, so it's going to be 1 over K is 0.5 and -3. So that is going to be 2 minus 3, -1. You got that right. And then A is just 1. I mean, A is 0.5. That's going to be 4 and then +3. Yes. So you guys should know how to do that. Shouldn't be a problem. Now, you will see on the textbook, this is basically sitting on the whole thing I'm talking about in 1.4. So I'm going to say on homework in textbook 1.4, you need to practice the 1.4 questions. So practice. If you didn't do 1.1, we did 1.2. 1.3 is not that much. 1.4. If I'm right, 1.3 is just basically talking about a graph of the function. So you won't really see anything as a questions in 1.3. Yeah. So 1.3, oh no, 1.3 does have question. Yes. So 1.3 has a good amount of question. All right. In 1.3, you're going to have a specific question. So we want to going back to some selected question in 1.3. So this is going to be the thinking question you are expected to see on your first test, 100% sure. Very interesting thinking question to think about. So I will show you a couple of questions how we should be able to answer. So question like this, you expected to see. They're going to give you the characteristics of the graph, and then you are expected to sketch it. So if you want to do that, sometime it's not necessary you will get the graph that you have seen before. It is not necessary the graph or quadratic or parabola or reciprocal, but as long as it's going to be follow the properties, that's fine. For each one of the following situation involve a parent function whose graph has been translated. Draw a possible graph that's fit the situation. So the first one, the domain, x belong to real, of interval of increasing from -∞ to ∞, and the range is x is greater than -3. Now, we're going to going back to think about this. So the domain is -∞. So what are the graph that we talk about that have the domain? Y is equal to x graph, y is equal to x squared graph. So y is equal to 1 over x not falling into this category. Y is equal to absolute value of x falling into the category, right? This is falling. Y is equal to square root of x won't falling into the category because -∞, +∞. Now, y is equal to exponential function falling into this category. Now, we can see that we have only option to choose from. Graph something like that, or something like that, or something like that, something like that. Now, you also have the restriction on the domain, x is greater than -3. So now I'm going to ask myself, where do we really put that kind of restriction? Because quadratic function, the restriction will be also included. The only place the restriction does not include if I have a graph like this, isn't it? Because we're going to see that fx greater than -3, and it's not going to be included. So for each one of the following situation, involve a parent function whose graph has been translated. So this is a parent function has been translated. They asked to do a rough sketch. You can have a rough sketch. This is going to be -3 here, -1, -2, -3. And then you want a graph spanning from -∞ to +∞, but also in that range. All right, so we're going to discuss the next one. You guys going to think about B and C. The ranges between 2 and 4. They doesn't specify anything about. It doesn't specify anything about the domain. The range is between 2 to 4. So let's see what kind of graph will have the range is bounded between two numbers. That's a little tricky one. Which graph will have a graph where the range is bounded between two numbers? Arthur? What type of graph will have the range bounded between two numbers?
Like probably like 1/x.
But 1/x is not bounded. The range is negative infinity to positive infinity. It doesn't including the zero, but it's squeezed between two values, right?
Yeah.
So you want a range to be squeezed between two values. So this is 2 and this is 4, isn't it? Make sense?
Yeah.
So if I want to have a graph that's range squeezed between two values, the only possible graph can be a sine or cos function. Because also the function is actually squeezed, isn't it? Because if you look at it, y is equal to sine of x, the domain of sine of x, the range of sine of x is basically between 1 to -1, isn't it? Hello? I
Yeah.
just seen a picture?
Yeah.
Okay. So how about C? The domain is x belong to real, but x not equal to 5. So what does that tell Harshini? When they say the domain is x belong to real, x not equal to 5, what that tells you? Domain has a restriction for a specific x value. What that tells you? Danish? It has a vertical asymptote, right? So it has a vertical asymptote x equal to 5. Now the range also have a restriction. What that tells you? So horizontal asymptote. So you have a function that has a vertical asymptote at x equal to 5. So that is 5 is going to be the vertical asymptote. Horizontal asymptote as -3. So possible graph. So it can be go like that. And then it can be go like that, isn't it? So example of the graph, y is equal to 1/x minus 5, -3. Are you guys following that? Hello?
Yeah.
All right. So these type of question, you need to practice it. You need to master it, what they're looking for. So let's look at the number 9. I want you guys to look at the number 9 to see if you can think about a graph. Sketch a possible graph that f at 0 is -0.5, f at 1 is 2. Vertical asymptote is -1. As x gets positively large, y get positively large. What that tells you, sir? When x gets positively large, y get positively large. What does that tell you? What is that they're trying to say? When x gets positively large, y get positively large. What does that mean?
What are you talking about? The graph?
Like the statement, I'm talking about the statement. If x gets positively large, y get positively large.
So the numbers became big.
Yeah, what is that mathematically? If x goes to Ramanujan, then y go to Ramanujan. What does that mean? If I say yes, if x goes to infinity, then y goes to infinity. Positively large mean goes to infinity. And then positive large. At x gets negatively large, y approaches 0. Right? So you're tasked to sketch the graph that satisfy those conditions. F at 0 is -0.5, f at 1 is 2. Vertical asymptote at -1. X get positively large, y get positively large. So how do we do that? I can show you how to visualize it so you can get a picture. These are the type of question we always put 5-mark question at the end. You can see that how this is 5-mark question. 1, 2, 3, 4, 5. There are five checkpoints to check. Very easy. Your teacher can come up with very creative to put the condition. So f at 0 is -0.5. So f at 0 means somewhere here. This is 1. This is 2. Okay, cool. I marked that point. F at 1 is 2. So that is f at 1. This 2, I mean, it's just that being just marked. There's a vertical asymptote as -1. So that I will mark the -1. I'm going to put the dot line. My graph cannot cross that. As x gets positively large, y gets positively large. So that means my graph's supposed to go somewhere here. That is what the point is. As x gets negatively large, y approaches 0. So that's two possibilities for us. So it can be the scenario here. It can be go here or it can be go here. We don't know yet, but those are the possibilities. So in that being said, let's look at the picture. I want a graph, something goes like this, and then there should be an asymptote, isn't it? There should be an asymptote. So that's that first part. The next part for me is, if this is an asymptote, how do I make the asymptote goes like that? Do you see that? So I can have an asymptote again going there. Why do I need to turn this way? Because I need to satisfy the last condition. As x goes to negatively large, my y need to go to 0. Makes sense? The key is sometimes your teacher try to come up with a graph. It's easy to make a mistake. I gave a similar question on my calculus class, I believe, yes. I tried to make it hard, and somehow I made a mistake. There's a one particular condition won't allow you to create a graph. So no one catch it. Then we're doing an exam, not exam review, we're doing the review, the test review. There's a one goal. Mr. Jake, this question has been haunting me. How would you graph it? Then I realized, oh, I made a mistake in a statement. Now, rather than just changing the denominator, I say I will give a marks back for everyone who got that correct. So, but these questions are very tricky. It will give a partial mark for satisfying each condition, but you really need to do practice to visualize it. There's no way that you can quickly sketch it, but you see that I put the condition to graph it. So this is in 1.3. There's a good amount of question from the textbook 1.3. No excuse, 1.3. So I'm going to say practice all the questions from the textbook. So not from here. On textbook. 1.1, 1.2, 1.3. Did I talk about 1.4? Yes, I did talk about 1.4. After that, you guys see the mid-chapter review. After that, you got mid-chapter review. Following the mid-chapter review on a textbook, so you can see mid-chapter review. Actually, we talk about sketch and graph of the function. That is what I'm talking about, 1.3. Then we're going to dive into inverse relation. So let's keep going, because when I finish this unit, I will be diving into, it's not a review, the real grade 12 content is polynomial function. So I think I'm on track, because after 1.5, if I'm right, it's talk about piecewise function, pretty straightforward. If I finish piecewise function, exploring operation with functions, we will do that at the end, so we're not going to worry about it. So you all got the inverse function handout, did you guys? I think I gave the inverse function handout, did I? Okay, so let me dive into my inverse function handout. I print that as a PDF, so that should be able to allow me to add here. All right. You guys have seen inverse function before. The way inverse function, if you have an x on the domain, you got a y, you got the y to get the x, that's the inverse function. The graph of the inverse function is a reflection of the original graph in y is equal to x-axis. If a comma b is the point on the graph of f of x, then b comma a represents the point on the graph corresponding inverse. So let's going back to sketch the inverse relation. So I'm going to ask Audrey, how would I sketch the inverse relation for the graph A? What should I do?
We just have to do like the opposite. So like it's gonna be like it's like 1 and 3, right? So it just has to be like 3 and 1.
Correct, you got it. So we're gonna mark the point. This point, -5, -3. This one, -3, 0. This one, 0, 1. This one, 1, 3. This one, 5, 5. So all I'm going to do is I'm going to switch this point. So this is -5, 3. It's going to be -3, -5. So I'm going to going back to -3, comma -5. So that's going to be somewhere here. Then -3, comma 0, it's going to be 0, comma -3. That's going to be here. 0, comma 1 is going to be 1, comma 0. This is here. 1, comma 3 is going to be 3, comma 1. That's here. 5, comma 5. I can't really do anything. So this is going to be, if you complete it kind of frog shaped, you're going to get it. Pretty straightforward if you join that inverse function. Right. Now, what they're saying is a reflection on y is equal to x-axis. You can also see 2, comma 2, 3, comma 3. So if I'm going to draw this line, you can see that it's a reflection on y is equal to x-axis. So to graph the inverse relation for y is equal to x squared, and we can simply plot the point. You guys are expert on that graph. All I have to do is 0, comma 0 is going to be here. 1, comma 1 is going to be here. 2, comma 4, 4, comma 2. That's here. That is going to be your inverse relation, isn't it? Hello. Now, something to note, not all the inverse relations are function, because in this case, I'm failing the vertical line test. So inverse of the quadratic relation is not a function, right? Fail the vertical line test. Now, what we want to do is we want to going back to how algebraically we should be able to find the inverse function. So most common one that you guys are going to see, quadratic. So determine the equation for the inverse. First step, y is equal to. First step, y is equal to. Something you need to know, quadratic function. Quadratic function must be in a vertex form. Must be in vertex form in order to find the inverse. Otherwise, you cannot find the inverse. So what is the next step? We'll choose the x with a y. Then we had to take the square root. Plus or minus square root of x minus 4 divided by 2, and then minus 3. Now the question is asking graph the inverse relation. Is this as a function? How do I graph the inverse relation? What we can do, we can draw the original function. Vertex is -3, comma 4. So -3, comma 4. And then you know the step pattern. So -3, comma 4. Step pattern is going to be going back 1, 3, 5. A value is 2. So 2, 6, 10, isn't it? Make sense? So that's being said. So if I have the point -3, comma 4, if I go back to -4, -5, -2, -1, I need to add 2. So 4 plus 2 is going to 2. Add 6, 8. And then that's going to be 2 and 8. So it's easy to graph it. So next point is going to be -4, comma 2. So, oh no, I didn't mark my vertex correct. -3, comma 4. So where is my vertex? -3, comma 4, so -2, -3, comma 4. Then my next point is -4, comma 2. So that's going to be here. And then -5, comma 8. And -5, comma 8. So -5, comma 8. Something is not correct. Why I'm not doing that correct? This is -3, comma 4. That's my vertex. -3, comma 4 is my vertex. Let me mark that. Step pattern is 1, 3, 5, 2, 6, 10. So if I add 4 plus 2, oh no, that's what I mean. 4 plus 2 is 6, what I'm doing. 4 plus 2 is 6. 6 plus 6 is 12, so that is 6, 12. So -3, comma 4, then -4, comma 6. -4, comma 6. And then you have, and then -2, comma 6. I put this point in the wrong spot. -3, comma 4. Then -2, comma 6. That's how the graph will look like. And then if they ask to sketch that inverse, -4 comma -3. So 4 comma -3, it's just going to be here. Then add 6 comma -4, 6 comma -4, it's just going to be here. And then 6 comma -2. So we can graph it. That's going to be the inverse. Kevin, are you following that, sir? Graph the inverse relation. Is that a function? No, it is not. Restrict the domain to state that. So what we can do, if I state the domain of this, where x need to be greater than or equal to -3, then what will happen? You're only going to be get the graph that's going through the -3. Then your inverse is going to be only part of it. So if I'm going to be ignore, guys, this part of the curve, then my inverse is going to be that part. That is passing the vertical line test, isn't it? So in a quadratic relation, if you restrict the domain of the function, we can have an inverse of that function. It's also a function. Harshini and Divya and Adre, are you guys following that?
Yeah.
All right. So let me show you how do I able to get. By the way, this class I will continue. So all I'm gonna do, people might want to join. They're gonna say, this particular unit, most teachers won't cover. They will go back to polynomial function. We will dive into polynomial function next class. So you're gonna say we are in polynomial function. You can continuously learn. So my goal is to if we go in a right pace, if you guys do the homework, I can finish teaching one of the major unit that you're gonna see for the first month is polynomial function. That's if you navigate polynomial function, there are 2 units of trigonometry, exactly grade 11. The only difference is radian measure. You're gonna see majority of the things exactly the same in 2 units. The logarithmic unit is pretty easy, very similar to exponential unit. So polynomial unit, if you navigate it, then it's pretty straightforward. All right, find the inverse algebraically. So if you want to find this one algebraically, first step, y is equal to square root of 2x plus 1. X is equal to square root of 2y plus 1. We're going to square both sides. Are you guys following that? Hello.
Yep.
To right. Okay. So the only piece of this unit I didn't talk about is called piecewise function. I will introduce piecewise function. Pretty straightforward. Let me go back to piecewise function. So what is piecewise function is? Shipping cost. Oh no. Piecewise functions. Piece. So here's the question. So your parents working, they're paying taxes. At the end of the year, you might have 2 jobs, 3 jobs. At the end of the year, they're going to be add all that income you make together. Let's say I make 75,000. So that is A. And another one make 125,000. B. Another one make $30,000. That is C. Question for it. Do you think the federal government will be charging the same percentage tax for all 3? Kevin, do you think the government will be charging? It's a 15.5% tax. A need to pay, B need to pay, C need to pay. What do you think? Why not?
Because someone who earns less will have less money.
Yeah. So if you're going to charge that, it's going to be communism, right? So the person who earned less, they might need to pay, just need to get the benefit, just paying less percentage in taxes. Now, next question for you is, let's say I'm saying that, hey, that you're making $30,000, you're going to pay 15% tax, and then you're making 125,000, 30% of tax. Now, does this make sense? Then how the people will leave Canada, man, if they're going to do that? 30% for the $125,000 is too much of money. You're just charging flat of 30% for 125,000. There won't be no company will come here. So what they do is they say the first 50,000, we're going to charge you 10% of tax. Next 50,000 to 100,000, we're going to charge 22% of tax. Anything above 100,000, we're going to charge 30%. So in other way, his tax is not going to be flat 30% because 125,000 can be break into first 50,000. There's another one falling into this category, another 50,000. That last 25,000 is falling onto this category, isn't it? Have you seen that picture? So we will apply 10% here, 22% here, 30% here. This is called piecewise function because you cannot have a simple formula for this. Based on a different x value, you're saying that the function changes. Whereas we're going to see this function shipping cost. So if you're shipping it, there's a flat rate, anything 10 kilogram, up to 10 kilogram is going to be $2 per kilogram. Doesn't matter if you put 8 kilogram or 9 kilogram or 5 kilogram, you have to pay. Then they say from 10 to 15 kilogram is going to be additional $5 per kilogram. Doesn't matter if you put 11 kilogram or 12 kilogram or 13 kilogram, within 50, you're going to pay it. So I didn't teach you piecewise function yet. I did introduce you inverse function. You can see on your textbook, there's a good amount of questions that in inverse function. So that is 1.5, 1.5, 1.5, 1.5. Yes, good amount of question in inverse function. So please do every question. So don't tell me that 1.1 from there, 1.1 to 1.5 from the textbook. I will see you guys next week. I think that I'm almost done with this unit. So we will dive into polynomial functions next week on Sunday. Pretty easy. You guys going to see in the beginning, but it will get more intensive in algebra down the street. But initially, it is going to be pretty easy learning with polynomial function. Harshini, make sure you come at 11:30 so you won't miss my lesson.
Yeah,
If you
sorry.
put that schedule, all right. I will see you guys next week.
Yeah.